wavefronts. What are these? These are the locus of all points which are vibrating in a same phase. So what is wavefront? It is a locus of all points which are vibrating in a same phase. Now what does this point locus means? You all are aware about the parabola. You all have read in your maths how parabola is formed. It is something like this, that this is a point O, and over here everything is going to meet. Okay, O, and here the rays are coming. Okay, so every time what is happening, the distance traveled by this, you can consider it as a wave also. Let's consider it as a wave. Suppose if our wave is traveling this much distance and from this point it got bent. Okay, it meets at point O. Suppose at second wave is coming and this wave is bending slightly lesser than to the first point. Let's meet it over here. Let's take another ray, another light wave, and it is bending at some further distance compared to this point at this point. Slowly and slowly, if we are decreasing, we got this one point. Okay, over here it suppose it bends from here. So when we are going to meet all these points, we got a parabola over here. Okay. Similarly, what happen in wavefront, when the waves are coming and some points are made, suppose these are the points and these are the points which is known as locus. All these points are going to vibrate in a same phase. Okay, all these points are going to vibrate in a same phase. That's why we are saying locus of all points. Okay, so this locus plays a very important role when you study about parabola, hyperbola and ellipse, circle, etc. Clear? So what is wavefront? It is simply locus of all points which are vibrating in a same phase. Now what are type of wavefront? So one of the simplest wavefront is spherical wavefront, which is simply formed by point source. All of you know very well how wave is created when some disturbance is created. If the source of disturbance, if this is a source of disturbance, if source of disturbance is point, if the source of disturbance is point, okay, if the source of disturbance is point, then we are going to get spherical wavefront. And suppose if the source of disturbance is linear, source of disturbance is linear, we are going to get plane wavefront. And what more is left? Sorry, cylindrical wavefront. Cylindrical wavefront. If the source of disturbance are linear, we will get cylindrical wavefront. If point and this linear going to meet, means if the source of disturbance is both point also and linear also, then we are going to get as a plane wavefront. If the source of disturbance is point, source of disturbance point plus linear, then what we are going to get? Plane wavefront. Clear? Now what does Huygens principle says? Okay, we will talk in another video for that. Thank you.